Okay, question 8. A solid cylinder of radius 18 centimeter is free to rotate about a smooth horizontal axle, and then a mass of 0.38 kilogram hangs from a string wound around this cylinder here. So when the system is released from rest, the mass takes 2 seconds to fall through a height of 5 meter. So what is the moment of inertia of the cylinder, and then discuss qualitatively the effect on the speed of the mass after the mass has fallen through a height of 5 meter, in which the cylinder is replaced with a hollow cylinder. Okay, in this case, we have to draw the free body diagram again, but before we start, let's consider the direction of the linear acceleration and the angular acceleration. So this one, it falls down, so the linear acceleration is basically going down, and then obviously the angular acceleration follows, so it should be somewhere like this. Okay, so this is the angular acceleration, this is the linear acceleration. Before we continue, I forgot to mention is solution number 7 yang sepatutnya how do we consider if the tension is positive or negative untuk this type of question is if it follows the angular acceleration, it should be positive. Okay, doesn't matter if it's anti-clockwise ka, clockwise ka. I think I've mentioned wrongly in questions in the solution number 7 lah. Just a correction yang it follows the angular acceleration mesti positive. Okay, now we can continue. So we have the axle, okay, and then we can draw the force diagram lah. Okay, so this is the tension, and then this is the something that you don't have to consider in the calculation. This is your force, this is the weight of the axle, and then the direction of the angular acceleration is this one. Then we have to consider the block, the cylinder punya pula. Okay, so the cylinder is sama juga begini. Okay, so now let's label. This is weight of the axle, this is the shear force, and then this is the angular acceleration. Oh, before we forgot, we have to consider the direction. So this is linear acceleration, this is the block punya mass, a weight, force, and then this is the tension. This is the tension as well. Okay, alright, lepas tu we are gonna use the formula total net torque. The net torque is equal to I alpha. Okay, in order for us to find this, we have to find the value of linear acceleration dulu. Okay, so how do we find the linear acceleration? We have been given the displacement is 5 meter. Lepas tu, we know that the initial velocity of the block is 0. So we can, and then the mass falls takes about 2 seconds to go through 5 meter of height. And then we can use as ut plus half at square. Okay, so s is 5, this is 0 plus half. A is what we are looking for, so we should get the value of acceleration to be equal to 2.5 meter per second square. Okay, so now we can continue. This is equation for this axle, so let's do that one. So TR, so kenapa tension dia sekarang positive even though it is going clockwise? It is because it is following the direction of angular acceleration. Okay, so if it follows the angular acceleration punya direction, it should be positive. Good. Then alpha is A over R. So we can then substitute lah dalam ni formula, which is we are looking for I. So I is TR square over A. Saya rearrange. I think so. Okay, and then we have to find the value of tension by using this situation here. Okay, so it is total force at Y equal to MA So mg minus t equal to ma. So t is equal to mg minus a. So this is around 2.778 Newton. So this one you can just substitute lah. 2.778, then radius of the axle 0.18 square over the acceleration, linear acceleration 2.5. Should get the moment of inertia to be equal to 3.6 times 10 negative 2 kilogram meter square. Okay, so that is the solution for 8a. And then for question B, if a hollow cylinder is used, the moment of inertia of hollow cylinder is greater than the solid cylinder, right? So the acceleration of the mass, is greater. Okay, so it is smaller. Okay, meaning that the time taken is longer ataupun dia increases lah. Okay, so that is the solution for question number 8.